Hello everybody, thanks for coming. I'll get started. So what is all this about? I'm going to talk about interactive objects, about inflatable soft robots, a bit of an origin story of how we got where we are as air giants, about why you should make terrible robots, and some thoughts about prototyping, and really on doing it badly. I should introduce myself. Oh, I skipped a slide. So we are air giants. We make giant inflated robots. So giant is 5 to 10 meters, big, soft, inflated things. We have backgrounds in robotics, in puppetry. We're very interested in robots which are emotionally effective. So, you know, we're not trying to weld cars together. And we like giant squishy things because everybody likes giant squishy things. This will be a bit of a meander around really, but I hope it all makes sense in the end. So let me start long ago with some things I made. This was Sketchy. So Sketchy drew pictures of people. It was a very wobbly little Delta robot with a brush pen on the end and a phone app, and it drew this kind of thing. It wasn't terribly good at drawing pictures of people, but it was surprisingly popular as a thing. People liked having their pictures drawn. People even liked having very bad pictures drawn. I learned that if you get more or less one thing that might be an eye or an eyebrow and a thing that might be a nose, and some kind of outline, then people will mostly regard that as a successful portrait. And that was an interesting experience, in part because it revealed a thing about why it was interesting to people to go through this. That it did a thing, and it was a thing that was about them, and it did something different for every person. So even though it was certainly not the best drawing robot in the world, it was an interesting experience to be drawn by it. This is the tuner stick. So this was built for a hacker camp. That big round thing rotates continuously, slowly. It plays music depending on where people are around it. So the people act as kind of like holding a punch card. The closer the people are, the higher the pitch. It has some trickery in it so that the music is always reasonably musical. It's not the best music in the world. It's always kind of okay, but it's quite engaging because it gives you a thing to do. It doesn't give you a thing that's difficult to learn, but a thing that you sort of have to learn. You know, people like to come and play with it. I mean, that's the upshot. This is the world of techno. So this is a thing on a trolley with a speaker and a GPS. It plays techno. It plays generative techno based on GPS coordinates. So the slogan there is a different tune for every square foot of the planet, which is about right. It really is different techno everywhere. I think only a bit different. Sometimes it only changes a little bit. Again, this was built for a hacker camp. I would literally just turn it on, leave it on a path somewhere, playing its funny little techno. Somebody would come along, find it, push it around for a bit, abandon it. Somebody else would find it. It's very popular. Again, I think not because the techno is great techno, but because it gives you the right kind of thing to do with it. to have an engaging experience. You know, you would just hear it wandering about the camp all day, playing its little tunes. It's not fancy. No, that's what's inside. There's a car amplifier, there's a Raspberry Pi, there's a bunch of code. It's built on Sonic Pi, which is great for this kind of generative music stuff. Speakers from a charity shop. Handle is literally out of a skip. I think it's easy when you're building this kind of thing to think you ought to build a great thing. You know, it ought to be really nicely made. It ought to be designed in every aspect. But as time has gone on, I've become more and more convinced that what matters is not what the thing is, but what the thing does. And that as long as it's robust enough and stable enough and it basically works, the rest of it should be made quickly, because then you can change it quickly. You can make another one when you found you made it wrong. And I guess that has been a bit of a theme for me. So that brings me to prototyping. If you make stuff, if you make interactive stuff, then you're going to go through prototypes. And a thing which I have learned slowly is that they should usually be terrible. That is, they should be quick. They should be simple and easy, and they should be aimed at telling you something specific. So these are some prototypes from a project I worked on. This was a Rusty Squid project. It resulted in a Channel 4 documentary called How to Make a Robot. Maybe it was How to Build a Robot. I'm not quite sure. It's no longer available on Catch Up, I'm afraid. A team of 12 of us designed and built a robot and then took it out and abandoned it in the street and saw what people did with it. It was semi-robot, semi-puppet, so it had its own behavior, it had a lot of motion, and it had somebody telling it some things about what to do. So it was sort of in between. We went through a lot of prototypes. So there's the finished thing. It could move its little arms. It had, the torso was quite flexible in twist and bend. The head was very mobile, and it had many parts. Here is one of the prototypes. So this was literally a bag of polystyrene beads that we already had. And the question we were trying to answer is, how big should the robot be? This didn't take very long to make. The answer was not that big. These were just testing for form and size. Again, they don't take long to make, but that lets you actually pick the thing up and go, is this the right size for it? Should it be stable when you put it down? Should it be wobbly when you put it down? These answer those questions. This was David McGoran puppeteering. So the prototype here is literally 2 sticks, a bit of laser cut MDF, I imagine, and some bits in a bowl kind of representing a torso. But that's enough. You know, that was enough to do some kinds of interaction to see if those were interactions we wanted. This prototype is actually Emma inside a box. You could feed bits of paper in, and then it would give you bits of paper back. But we learned that people like that interaction. In the end, we didn't use it in the robot because it's hard to work out what the piece of paper that comes out ought to do, and because understanding what the piece of paper that came in is quite computationally difficult. But as an interaction, it worked great. It's just hard to make if you don't already have Emma in a box. Testing, just a size test, you know, size and texture. That was hugely informative. I think that was actually a cushion from IKEA with a couple of bits of tape on it for eyes. To trying teeny little arms to see if we like teeny little arms, to see what the gestural possibilities of teeny little arms are. In the end, we went with teeny little arms. That's enough. You know, they weren't for picking stuff up; they were for gesticulating. You know, cardboard and MDF and Lego. Even when we started making things with technology in. So this is a bit more finished. The arms are a bit bigger. There were some antennae that we tried, and a very quick kind of cloth cover. Testing squeezy interactions. This thing lit up more when you squeezed it more. That's a very early cover on kind of the finished mechanics. Didn't work because it didn't show the flex very well. But you know, formative. There's the finished robot, sitting in the street in the rain. This is fixing it in a cafe. There was a certain amount of fixing. Turns out if you make robots and then you take them out into the street, they break, and you have to find a cafe to fix them in. And that's a fairly typical encounter. So we're filming from across the road. None of those people are our stooges. We probably handed it to one of those people and walked away, or they just picked it up off the ground, and then some other people came and had a chat. It said a few things to them. It wiggled about. Turns out it's cold work doing this, but hugely rewarding. So a thing that I learned from this that I hadn't really got before was about how you can make an engaging robot by using really techniques from puppetry. So if you give your robot a way to show attention to people, if you give it some lifelike kinds of motion. So for example, this robot had a head which stayed moderately level however you held it. It had some very simple image recognition, so it tended to focus on the faces and then to stay locked onto that face as you moved its body around. It had a simple kind of breathing-like motion going on. And just that is enough to give you a really strong feeling that there's something alive in there. You know, it worked on me, and I sort of knew what was inside, but it still felt that way. So I learned a huge amount from seeing this, and I found I was very interested in getting that kind of emotional interaction into a robot, and making it a thing that people would want to spend time with. So let's go on to inflating things. This is the giant staring eye. It's an eye and it stares. That's really all it does. It looks for motion. It looks towards motion quite slowly. The iris size changes when it's interested. Very interested now, so the iris is very big. That was the first real inflatable thing that I'd ever made. This is what's inside it. So not much really. The light bulb in the center. The little disc casts the shadow, which is the iris, or the pupil rather, and that moves back and forth along those rails, pulled by a servo and some string. The blue thing is the iris, casts a big blue shadow, that doesn't move, and then this whole thing can move around a vertical axis and up and down, so it can look at things. And that was inside a sewn fabric envelope with a little blower to keep it inflated. It was an interesting thing, and people were interested in it when they saw it, but they were not interested in it for very long because it didn't offer a very engaging interaction beyond it's looking at you, and then maybe you move around to see what it does and it's still looking at you, and then you're kind of bored. And I kind of what I guess I learned from that was about the difference between an interesting thing and an interesting interaction. There's not much engagement. Nobody wants to spend a lot of time with it. They like the idea of it, but it hasn't really made their day better. But also, sphere, I really liked it. It was this big kind of solid shape. It was soft, but not so soft it couldn't hold itself up. And crucially, if you want to make big robots, you could put it away. You could deflate it, and it was tiny, and that is a good thing. So this is the only robot I know how to make out of office supplies. I mean, barely a robot really, just an actuator, but it spawned some ideas. So that's made from 2 pieces of paper cut into a wiggly shape, stuck through the laminator, and then all the excess laminator stuff cut off. So it's a very quick way to make simple, flat, inflatable things. You can get a lot of interesting motion from them, and because the laminator plastic is quite stiff, it always goes back to roughly its starting shape. So you don't have to make something to provide a force going in the other direction. I'd encourage you to have a play with this if you like inflating things, just because it's really easy. It's a good way to test ideas. I guess this is kind of a walk through the history of inflating things. So this is not my project. This was an MIT project called Aeromorph. What they've done is made a CNC fabric heat sealing machine, and then designed a couple of, in fact, maybe just one specific actuation to do with it, which uses these diamond shapes. So anything with those diamond shapes, when you inflate it, it will curl. Which way it will curl can be slightly unpredictable. Also, it's not terribly strong. But it's a sweet project. I was quite inspired by it. They got a lot of different shapes going. That led me to this. And again, you can see this is my enthusiasm for very low rent prototyping. This is 2 bits of fabric sealed together by hand using a variable temperature soldering iron. This one has a rib of glue gun glue to give it a little stiffness. So there are 2 chambers, one on each side, and as you inflate one chamber or the other, you can make it curl one way or the other. I made a bunch of shapes in this, just trying actuation strategies. And this is what's driving it. So these are air pumps from eBay. These are blood pressure meter pumps. Which are 3 quid. Similarly, these valves, like 3 quid or something. Arduino to drive it. Very simple stuff, but enough to support a lot of experiment. It turns out a lot of the time when you're inflating things, you are looking for different sources of air at different pressures and volumes, which is always frankly annoying. That led to this. So my friend Robert, who is also one of the founders of Air Giants, worked out how to do this CNC heat sealing, so we could make much tidier things. And so this was a pair of ears. They're wearable. There's an accelerometer on them. They will sort of exaggerate the motion of the wearer. They're quite effective. They look like the wearer is operating them deliberately. Not much force in them, but you don't need much force for this. So obviously, I was slightly obsessed with inflating things. This is a complicated but workable thing we call the giant tentacle, because it's a giant tentacle. This has permanently inflated parts acting as bones, and then these semicircular chambers driving the joints one way or the other. A system of hoses and valves, you can see all the hose underneath, and little rangefinders. So those little black dots in the middle of the bones are short range, time of flight rangefinders. So it has this very vague idea of what's near it, whether something is there on one side or the other. And it plays a little game. I mean, it really has two games. One game is try to catch the person, and the other game is run away from the person. And it switches between those fairly randomly. And people mostly understand the game it's trying to play and go along with it. There are not many cues there. Nobody's telling them what it's up to, but they kind of understand that that's what's going on. Some people really think that it has a head. It's interesting. I had never imagined that this was what's going to happen. But some people go up to this pointy end and they start trying to get its attention. They're clapping and waving their hands in front of it. Some people just don't think that. They see it more as a tentacle and don't focus on one part. Some people just want to hug it. That's quite a common reaction. Some people just want to stick their heads inside the hinges and get squeezed. That's not very common, but it's definitely a thing. People just like a big soft squeeze at the head. Who knew? I didn't know. So this is much more of a engaging interaction than the eyeball. It gives you a thing to do, and it gives you a thing that people enjoy. And I think partly they enjoy it because they have this feeling that there's some intention in there, that they're going along with this other being. I mean, they know it's not really a being, but it feels like they're going along with what this other being wants to do. The plumbing's a problem. It's just there is packed up. So this thing in the right there is the block of valves that runs it. You can't buy valves for this, you have to make them. So it's not very technical. It's all laser cut bits, ducting parts from Screwfix, radio control servos, but just lots of pipe. So the most important prototype ever created, well, at least for me, other people may have prototyped other things that made more difference to them. This thing. I didn't have any idea if this was going to work. I kind of hoped it was going to work. This was built on some ideas that had come out of the heat sealing experiments and the laminator experiments. It's this three-way structure. I sort of thought it might do something a bit like this. Actually, it really did something like that. I was kind of amazed. So I made a bigger one. Oh, that's not what I wanted to happen. There we go. A bigger one. So this is the Trifid. This runs off a bouncy castle blower. Video will catch up in a minute. There we go. So at this point, this was not at all autonomous. It's being driven by this child you can see on the right, the white controller. It turns out if you make an arbitrary controller and give it to an arbitrary small child, they can basically always work your robot. They're kind of used to game controllers and games that have this arbitrary mapping between controller and what happens, and they just work it out. It's kind of amazing. It always works. We took the Trifid to EMF Camp, a UK hacker camp. They actually sponsored the making of it. They paid for materials. It spent a lot of time waving about. A lot of people were very fond of it. this lady, she was Australian, she really loved it. She just kept coming back to have a big squeeze. This tactile thing was a surprise to me. It's really a thing that some people are very, very big on. So, air giants. All right, so having seen the tentacle and the trifid, it seemed like there was some juice here. You know, there was some interesting stuff that it would be wonderful to be able to work on more. Previously, I've been doing this work in my spare time, and these things, I mean, they take time to make. It was just hard to get the time to make enough things. My friends Emma and Robert were both very interested. Emma is a designer, puppet maker, all kinds of maker. Similarly, Robert has a long history in electronics and robotics and making all the things. I'd worked with Emma on the Rusty Squid project, so we knew we were both interested in this kind of work. And we got a grant from the Southwest Creativity Network, which was a scheme set up to start new creative technology businesses in the Southwest. We're very grateful to them. So they funded us from February to October 2020 to make Giant Joyful Robots. We're focused on robots which can have these individual close-up interactions and which have this feeling of being an alive thing. Most large robots you basically never see, or if you do see them, they're behind a fence or you can't get to them, because large robots have to be so powerful to move themselves that they could just kill you and not even notice. So there's a lot of novelty just in having a huge moving machine that people can be up close with. But we're also really interested in alive and engaging things, so things that are not just presenting you with a puzzle or a spectacle, but some personal real-time engagement. We did R&D. So there was a lot of R&D. So this is really about working out how you even do actuating large cloth structures with air. We spent a lot of time, this was in Emma's workshop, sewing things, quite often having an idea, sewing a thing, predicting what it was going to do, inflating it, finding it did something completely different, laughing and doing it again. It's interesting that our intuition about how things are going to respond when inflated is so poor. I guess ours is a bit better now, but you know, it's still not terribly good. So yeah, we spent ages just making stuff and putting air in it. We made things like that. And that. And this thing. Really looking for actuation strategies, fabrication strategies, ways to work with this material, which people have not worked with much. You know, there's a world of fabulous sculptural inflatables. People like Airworks, for example. They make amazing things as stage sets and display pieces and this kind of stuff, but moving inflatables are not very common, and usually when you find them, they're either just worked as sort of marionettes with ropes, or they have a frame inside, and we didn't think that was as much fun. So then towards the end of that period, or the grant from Sewell, really the idea was start a business, do some R&D, do a demo, build a prototype. So our aim was to build one fabulous prototype for the end of this to show what we could do with this as a technology and what we wanted to do with it as a business. We were very lucky to get the use of this enormous space in Ashton Court from Art Space Live Space, who rent out spaces like that to artists. It turns out if you want to make an 8-meter inflatable, you need a much bigger than 8-meter room to do it in. And so here we are sewing stuff. There's a sewing machine at the far end. There's a test piece for a neck joint. And this thing with all the tubes is a kind of universal air controller, which again is mostly made out of fabric because that's what we do. This is what we made. This is Luma. Luma is kind of a snail. We get a lot of that. People love to come up. People want to come and talk to the head. That's really a thing with Luma. That's where you go when you're dealing with a being. You talk to its head. We took Luma to Ashton Court for an event called We Are From Dust. This was our biggest fan. This little kid kept coming back to play with Luma. He's the child of a friend, I think. So apparently this boy cried all the way home because he had to stop talking to Luma. We felt slightly sorry for him, but also kind of weirdly pleased. If you can be pleased by a small child crying. Yes. So how it works, well, it's kind of a big question, but we make big valves to control flow through these things. We have blowers, bouncy castle blowers, which supply a constant supply of air, so they don't have to be sealed tight. They're not like beach toys or something where you need to have welded plastic structures to keep the air in. We have a lot of air going in, and then we have big valves that let air go in and out of different chambers throughout the thing. We have computing scattered through it so that each bit has its own local computing. That keeps the amount of cabling down, it keeps sensing near the actuation. That's just a convenient way to build a big robot, really. Those nodes are all on a CAN bus so they can talk to each other. The lighting is also locally controlled because that makes it easier. And then the behavior is managed centrally by a single thing that basically knows what we think we're up to. And then the sewing. I mean, it's just a lot of sewing. There's a lot of patterning and cutting out and sewing very long seams. That kind of is our life. So what's it for? Well, we think there are a lot of things that we can do with this stuff, but what we're really doing now is trying to have a business. So what we're starting with is performance, art, festival stuff, things up close with people, aiming solidly at things which are emotionally effective, which are engaging because they're alive. If you want to see Luma, come to Frequency Festival on the 31st of October. Luma will be there doing Luma's thing. We would love to see you. We think the scope of what it's for will widen in the future. We'll find more things to do with this stuff, but we have to focus somewhere just to get going. So yeah, this is our life. Here's our workshop. It's just an industrial unit. It's not fancy. It's not even warm, but it's a place to make things and sew things, and it's big enough to try what we're currently working on indoors. We can see that we will outgrow this, and when we do, we need to find a bigger space. We're just going to have to. So, for us, the business, and you work at Coral Avenue, which is a commission for Warwick Arts Centre. We'll be on show tomorrow and over the weekend. If you're near Warwick, come and have a visit. We'll be showing Luma at Frequency Festival this autumn and a couple of other places. We are working on audience sensing and making interaction autonomous. So at the moment, for example, Luma is puppeted, but by the time we get to Frequency Festival, I think it will be autonomous. that is sort of technical robotics work and puppetry work to make that effective. But we think that these things will be more exciting when they have their own identity and performance. So that's what we're doing. We've got some R&D going, so we're working on how to make quieter and smaller creatures that can run indoors and that are easy to send, you know, packaged up so that we can just send them to people. They don't have to be rigged. They don't need us there to set them up and plug them in and all that stuff. Starting some academic collaboration. So we've got one thing beginning with testing the idea really of using soft robots as body language prostheses. So this is for people with communication difficulties who at the moment often have communication aids that are aimed at very simple functional purposes. I mean, there's necessary stuff. No, I want tea now. It's the thing you have to say, but that doesn't cover the conveying of mood via body language, for example. And we think that might be a thing. We have academic collaborators who know much more about that part than us. We're currently looking for funding for building a much larger display piece for next summer. If you would like to help fund that, please get in touch. And we're looking for other collaborations. We think there's a lot of interesting stuff to do, both creative and academic. Please send us mails. We're via our website or send me a mail. We would love to talk to you. We would love to talk to anyone, really. Conclusions. So I'd suggest if you're going to start any kind of public art business, you don't do it during a pandemic. Although we've weathered it okay, but we've, I think, been lucky. It could easily have gone a different way. I mean, the markets that we were originally looking at, you know, lots of them happened. Everything didn't happen this summer. A lot of stuff didn't happen. It's starting up this autumn. It's a very bad time to start this business. We got lucky. You know, if we'd begun our trajectory a year earlier, we would have been up and running and had stuff ready to go, and then suddenly had nowhere to sell it. Could have been disastrous. Another conclusion, and this is the one that I think I'm the most enthusiastic about, is this story of inflating things for us has been, you know, it's long. There's a lot of years in it, in sort of doing a little thing that doesn't seem like much, and then doing another little thing that's based on it that also doesn't seem like much, but it's still kind of interesting. And that's been very gradual. It's taken place over years and lots of different little prototypes and playing with things. And some of them were projects in their own right, and some of them were just private little experiments. But there's something there about finding something that feels like it's got some juice, and then just sort of poking at it to push it along a bit, to find a new weird thing. Because, you know, there are lots of things that nobody's done. There's a huge number of things that nobody's done that it would be really interesting to do, but it's quite hard to find them. And so if you sort of feel like you've got your hands on one, on what might be one, you should just keep working on it, keep pushing it along and seeing how it grows, because that is a way to find genuinely new and exciting things. It's just slow. It's not even loads of work. I mean, it just takes time of thinking of things and trying things and waiting for it to ferment in your head and then trying it some more. So there's a Feynman quote I read the other day. I couldn't find it written down anywhere, so I didn't make a slide for it, which was roughly, if you learn about a thing and then you learn more about a thing, and then you just kind of keep trying to learn more about it, sooner or later you know more than anybody else. Because there's so much stuff to learn, actually it's not that hard to get into the territory that nobody's looked at yet. And so I would strongly encourage you, if you're of the mind to go and build weird robots or any kind of weird thing really, to just pursue whatever weirdness you find and keep digging wherever you see a little bit, just gently. You know, it doesn't have to be rocket science. You just have to keep doing it, and then in the end, something strange may emerge. I mean, it might not. There's no guarantees, but it's worked for me. And then the third thing is about prototyping. So, because we've done a lot, I've always done a lot with these things. It's easy to get stuck into a kind of a trap of trying to make a really good thing first off, when it's nearly always quicker to make a really bad thing. You know, make it in the easiest way you can. Make whatever you can think of off the top of your head that kind of addresses what you want to make, and then make it, and then just see what it tells you. It'll probably tell you something. It almost always tells you something that you didn't know before, and then the next one will be better. And that stops you investing loads of time in an idea that's not that great, but it also turns your okay idea into a really good idea by letting the object teach you. Let the prototypes teach you the stuff you didn't know. It's often so easy it doesn't feel like work. You just try a thing, and then you know a thing, and then you try another thing because it's kind of obvious what you ought to do, and you keep doing that, and soon you've got an amazing thing. Oh, and sometimes, actually surprisingly often, the thing that you thought was kind of a terrible prototype that nobody would want and it wasn't going to be good enough is actually good enough, and that's the final thing. You never need to make the really nice one because you've made one and it's effective. You know, it works well enough to provide the experience that you wanted, and you wouldn't get a better experience by making it better. So making things badly is just extremely powerful way of making things at all. I would strongly encourage you to try it. I think that's it for conclusions. Got any questions? Very happy to answer questions. Okay, so there's a question from Steve Battle in the chat. The favorite fabric. Ripstop is good for small things, but it's not strong enough for big things. So as you get larger at the same pressure, the stress in the fabric goes up. I think linearly. I should know that better, but I think linearly. Ripstop quickly becomes not strong enough. What we're working with for these is I think it's a 4-ounce nylon, which is the kind of fabric that a really cheap backpack might be made from. Nylon is very strong. It comes with a proofing on it, which makes it basically airtight. If you want to make things at lower pressures and smaller sizes, ripstop is good, but a bit crinkly. Balloon fabric is also good. It's light, it's more flexible than ripstop. What you really need is airtightness. So, you know, make a bag of it, sew up a bag of it, blow some air in, see if it stays up for a little bit. That's the test. Any more questions? Okay, Becky says, do you have moments where you look at your giant happy robots and think, what am I doing? Why am I doing this? Honestly, no, but it's a great question. I love them. We all love them. They're just, I mean, speaking for me rather than anybody else, they're just lovely, and being able to just go and make them all day is a fabulous opportunity, and I feel very lucky. I think it helps that there's more than one of us. I think doing it on your own, it's much harder. Even on my experiments I did on my own, I always had an audience from them. I had friends who were interested, and who were also people who made weird stuff, who I could show things to and get some reaction. And I think that is important for me, because it's kind of a sanity check that I haven't just made a boring thing that nobody cares about. So maybe that's a tip, that having some kind of a home crowd that you can show stuff to. But yeah, that's all I got for that. So Steve, yes, I think there are a lot of kids workshops you could make out of some of these things. You know, puppets made from card, little robots made from card, quick to make, children can make them in their own shapes, stick a couple of servos in them and you've got a thing that does a thing. Yeah, it seems like a no-brainer to me, but I don't do kids workshops for a living. But again, that sort of speaks to the point about making an emotionally appropriate thing. It's like the kids are interested in it sort of looking like how to work, but that they require you to learn what they want, which people do effectively, and then people are happy with them, but they're never simple. And I think that is something to strive for in this. Now, if it's too simple, then it's like the giant staring eye, which is great but not compelling. Zara, yes, we hope to be able to make ones which can be products, if you like, because we think people would like that. We think that there's a market for that. We'd love to make them. There's a lot of technical work to do first, just to make them reliable and comfortable indoors and easy to run. And if you ask me again in 6 months, I will have a much better answer to that question. So Chris, you asked about using air to voice the robots. We thought about it. I have had a little experiment. I tried sticking harmonicas on the air supply to the tentacle, in fact, and it was hilarious, but also kind of annoying. I think there is definitely a role for sound with these things, because things that are alive have sounds, and because sound to go along with motion and with light works very nicely. Using the air to do it is great, but also its own level of extra complication, because you have to make a bunch of instruments or find instruments that you think would work with it. We're using probably the right kind of air supply for organ pipes. I think it would be great, but it's more of an art piece than what we're aiming for right now. I mean, we probably will in the end. Yeah, seems inevitable in the end, really. I know where to buy surplus organ pipes. So Steve, that's a good question about the ethics of making something appear alive. And I think the answer I would give to that is really, if you look at a child playing with a stuffed toy, it's a very human thing to take something which is not alive and to treat it as though it is alive, with some limited scope. You know, a child doesn't invest their soft toy with all the consideration that they would give to their friends. They're perfectly capable of throwing it in the corner or stamping on it or whatever. I think the idea that something is alive for the purposes of imagination is something people do all the time, and it's very normal. It would be very bad to try to make something that was apparently genuinely alive in order to manipulate somebody or in order to trick them into something. I think that would be awful. But I think people are very understanding of aliveness as a game or as a sort of state of imagination, and they're totally up for that. I mean, they'll do it to things that are much less alive than our things, so we're quite happy with it. Does that make sense? Any more questions? That is a good question, Andy. We think, yes, there are ways to make wearable size things. In fact, one of our friends has made some wearable but non-actuated inflatable, kind of like Viking horns, big inflated horns on a hard hat with some little blowers in, illuminator on the inside. Looked great. Yep, we could do tails. The tails need a bit more power because ears don't have to do much. They're light and they don't move very far. A tail has to be longer and move further. So the question then is, what are you going to use to provide a quiet, portable air supply that you don't mind carrying about? We use proximity sensors to let them interact directly. Yes, our plan is to make them genuinely interactive, genuinely autonomous, so they know where people are around them and they are behaving entirely on their own in response to those people. In fact, the piece we're showing in Warwick does some of that, and we plan to work more on that because we think there's a lot of interesting juice there. We don't want the audience driving the creature. That's less interesting. I did spend a very happy evening once just letting people drive the Triffid, and what they mostly wanted to do was whack their friends with it. But that was hilarious. Everybody had fun. But making the things alive on their own, I think, is where a lot of the fun is. So position sensing. So yeah, if you want to make any of these things effective, they have to be in control of their own motion, and often that means you have to have position sensing. So in the tentacle, I started out trying to sense the angles at the joints with little arms with potentiometers on. That worked very badly. And then Tom had the genius idea of just putting a compass in each of the bones and then working out the angle from the compass, the difference in the compass angles. That worked great. The tentacle knows where it is quite accurately, and that enables it to remember where people are because it knows when it saw them with its tiny little sensors. And we need that kind of sensing in all of our robots, really, to just so they're in control of their own selves. You need that to do anything above some simple level of complexity.